So now second generation sequencing technologies have been developed. Second generation is faster and cheaper than first generation. So Roche has developed 454 pyrophosphate sequencing, Illumina has developed Solexa sequencing, and ABI has solid sequencing. I'll talk about Roche's and Illumina's technologies, but not about ABI's because it's a little complicated. Currently, third generation sequencing technologies are being developed, and they should be cheaper and faster yet. 454 sequencing. This animation will help to illustrate the process of 454 sequencing. In the first step, the DNA is fragmented into pieces 300 to 800 base pairs in length. Next, adapters are ligated to the end of each fragment. The adapters will help these DNA fragments bind to the beads used later and the polymerase. Each of these DNA fragments will bind to beads. Each bead gets only one DNA fragment, and this is ensured by adding a large excess of beads in relation to DNA fragments. And here you can see the fragment binding to the bead. Next, the DNA fragments are amplified with PCR. This is an emulsion PCR. The bead will be loaded into the wells, as you see now, and DNA polymerase will bind to the DNA fragment. Nucleotides are washed over the well one at a time. If the nucleotide is complementary, the polymerase will add it, and if not, it obviously won't add it. With the addition of each nucleotide, the pyrophosphate reaction will emit light, which is captured by a CCD, which is the same as what's used in digital cameras. The amount of light emitted is proportional to the amount of nucleotides added, as you see in this graph. The problem with pyrophosphate sequencing is that after about 6 base pairs, you can't really tell how many base pairs are added. The peak looks the same, so you can't tell whether you have 6, 7, 8, etc. base pairs.